remember yesterday we saw how light bends when it goes from a less dense medium like air to a more dense medium like glass at an angle?
You sure do.
Well, we can use this property of light to do many useful things. Take a look at this convex lens, for example. A convex lens is simply a curved piece of glass which is thicker in the middle, but it can bend light in such a way that it can magnify objects, like this dart, for example. Light rays from the head and tail of the dart bend as they enter the glass at an angle. The rays cross at the focal point of the lens, later forming an enlarged image of the dart. The magnification is equal to the distance of the image from the lens divided by the distance of the object from the lens. In this case, 2.
So microscopes and telescopes must have powerful convex lenses in them that magnify.
Exactly. In fact, this microscope here uses 2 convex lenses to increase its magnification power. Let's look at this integrated circuit chip and see what it looks like.
Is that like computer chips that store information on computer games?
Right, Larry. There are fascinating small structures on this chip that we can't see with the naked eye. But with the magnifying power of the microscope here, it opens up a whole new world to us. You want to see?
Yes.
With the chip in position, I could see the power of the microscope's 2 lenses to magnify nearby objects. Details invisible to the naked eye were suddenly crystal clear. Professor Johnson explained why.
The first lens focuses the light, and the second lens bends the light sharply towards the eye. The eye sees the light as if it traveled in a straight line, therefore seeing an enlarged image.
I saw another example of magnification the next day when Professor Johnson took me to CU Boulder's Summers-Bosch Observatory to look at Jupiter through its reflecting telescope. She explained its 24-inch reflector focuses light from distant objects in front of the eyepiece lens.
Okay.
Then it was my turn to take a peek, and a planet millions of miles away came into view.